What is converse, inverse, and contrapositive? Today, I will be telling you the meaning of these three components. But first, we must know what is a conditional statement. Conditional statement. A conditional statement, symbolized by PQ, is an if-then statement in which P is a hypothesis and Q is the conclusion. The logical connector in a conditional statement is denoted by the symbol. The conditional is defined to be true unless a true hypothesis leads to a false connection. So, below we will identify the hypothesis and conclusion of my given conditional statement. So my given conditional statement is, if it is a 90-degree angle, then it is a right angle. So, what here is the hypothesis and what there is the conclusion? Answer: in that conditional statement, the hypothesis is if it is a 90-degree angle. For the conclusion now, the answer is then it is a right angle. Our first component is converse. What is a converse? Converse, it is a converse of a conditional statement, meaning you just have to interchange the hypothesis and the conclusion. Means that the conclusion now will be the hypothesis, while the hypothesis will be the conclusion. We will follow the example as shown below. My given example is, if it is a 90-degree angle, then it is a right angle. What's the converse? Here it is. If it is a right angle, then it is a 90-degree angle. What's the lesson in this? We just have to interchange the hypothesis and the conclusion. Our second component is inverse. What is an inverse? You just have to negate the hypothesis and the conclusion. We will follow the example as shown below. My original conditional statement is, if it is a 90-degree angle, then it is a right angle. What's the inverse? Here it is. If it isn't a 90-degree angle, then it isn't a right angle. What's the lesson in this? We just have to negate both the hypothesis and the conclusion. Contrapositive. What is a contrapositive? A contrapositive is the inverse and converse of a given conditional statement, meaning first you have to converse or interchange the hypothesis and the conclusion in a given conditional statement. Second, you will negate both the hypothesis and the conclusion. So, my given example is, if it is a 90-degree angle, then it is a right angle. So what's the contrapositive of this conditional statement? Here it is. But now we transform it into, if it isn't a right angle, then the angle isn't 90 degrees. What's the lesson in this? You just have to interchange first the hypothesis and the conclusion. And then afterwards, you have to negate both the hypothesis and the conclusion. Conclusion. Since a conditional statement and its contrapositive are logically equivalent, we can use this to our advantage when we are proving mathematical theorems. Rather than prove the truth of a conditional statement directly, we can instead use the indirect proof strategy of proving the truth of the statement's contrapositive. Contrapositive proofs work because if the contrapositive is true, due to logical equivalence, the original conditional statement is also true. It turns out that even though the converse and inverse are not logically equivalent to the original conditional statement, they are logically equivalent to one another. There is an easy explanation for this. We start with the conditional statement, if Q then P. The contrapositive of this statement is, if not P then Q, then not Q. Since the inverse is the contrapositive of the converse and inverse are logically equivalent. Thanks for watching.